Okay, guys, I thought it was time to have a crack at Northern Hemisphere Exam 2. Hopefully, I'm switched on enough to do it. A little bit tired, but let's see how we go. Um, this is my first crack at it, so yeah, let's see what the questions are like. Okay, f of x is cosec x is transformed by a dilation factor 3 from the x-axis. Oops, so 3 cosec x. Don't forget you don't have to write this. 1 to the right, so that's f of x minus 1, so it's going to be that minus 1. Dilation of half from the y-axis, which is f of 2x. So 3 cosec 2x minus 1. So it is this one here. Remember, when it's f of 2x, you're just replacing x with 2x. Okay, tan squared x into that equation. So f of x is equal to square root tan squared x plus 1 on tan squared x. Tan squared x plus 1, is that sec squared x? I can't bloody remember. Tan squared x plus 1, tan squared x plus 1. Yeah. Okay, so okay, so that could be, that's sec squared x when you square root it. It could be plus or minus, like it could be mod, but because it's between 0 and pi and 2, it's just going to be sec squared x square rooted, which is going to be sec x, on tan squared x, which is sine squared x on cos squared x, which is cos squared x on sine squared x. Of course, that's 1 on cos. So that's going to cancel with that. And I'm going to have cos x and 1 on sine squared x, which is cosec squared x, which hopefully is, it is there, D. Okay, the implied domain, oof, that's nasty. Remember that cos is cos inverse. So 3x on pi on 2 cos inverse 2x 2 minus x. Okay, so what did I say? 3x divided by pi on 2. Was it pi on 2 minus cos inverse 2 minus x, I think. Cos inverse 2 minus x. Okay, and it copy. Let's go into here. Make sure, paste. Calculator is in radians. Sketch it. Zoom auto. Okay, so that looks like it's defined from 1 to 3, not including 2. Is that there? 1 to 3, not including 2. That looks like E to me. You could be more precise and check it, but we won't have time. Okay, so on the diagram, 4 cis 2 pi and 3. Okay, so it's got a length of 4 and my angle's negative 2 pi and 3. So negative 2 pi and 3 is going to obviously be along here. If it's got a radius of 4, then it's on this circle, so it's going to be S. Okay, what's this one? Specified domain. So, x plus yi plus 2, x minus y I plus 2. So we could say that that is x plus 2 squared minus that and that, because we could make it a difference of 2 squares, minus y I squared equals 4, which means it would be x plus 2 squared plus y squared is equal to 4. So the center's at negative 2, 0, and it has a radius of 2. Negative 2, 0, radius of 2, so it is B. All I did there was make that a difference of 2 squares because I know I've got plus or minus here, and that would factorize to give us x plus 2 squared. Okay, given that that is a factor, okay, so we know is false. We know that's true because that's a factor when I sub that in. We know it's conjugate because it's all real numbers. That's also going to be a factor. P of z has 3 linear factors over C. Yeah. Has no real roots. Has 2 complex conjugate roots. We know that's true. I wonder what happens when we factorize it. We can just do it on a cas. Z cubed plus 2z squared z cubed plus 2z squared plus 9z z minus 18 transformation factor plus 2z squared. Change it to be complex. Why isn't it working? Z cubed plus 2z squared plus 9z plus 18. It's a plus. Okay, so I've got minus 2, I've got 3i, and I've got minus 3i. And it's false. It does have a real root. The real root's negative 2. A gradient line that's perpendicular to that at the point 1, 2. Okay. 3y squared minus 5xy minus x squared. Okay, let's clear this. It was 3y squared minus 5x times y minus x squared equals 1. We want to mdiff it. Calculation mdiff. Okay. Whoa. Is that right? Oh, I stuffed that up. That was y squared. Okay, and x is 1, y is 2. So, given x equals 1, and then given y equals 2. What? Stuff it, let's just put it in. Negative 2 on 3 plus negative 2 divided by 3 plus 2 divided by 9 times 2 squared is 36. Negative 11 on 18, so it's perpendicular would be 18 and 11. I'll stuff this up. Okay, let's do it again. So 3y squared, it's probably quicker to do it by hand. If I derive that with respect to x, I'm going to get 6y dy dx, and then minus, derive that with respect to x, we just get 5y. Derive that with respect to x, they're going to get negative 5x dy dx, and then minus 2x equals 0. So we get dy dx is equal to 2x plus 5y on 6y minus 5x. If x equals 1, y equals 2, I'm going to have 2 times 1 is 2, plus 15. What did I just do? Plus 10. So 12 on 12 minus 5, which is 7. So if we flip that upside down, it's going to be negative 7 on 12, which is D. Should have just done it like that in the first place. I don't know why I stuffed it up. Okay, this to me looks like a tan substitution, because if I make that U, which all of them have, we want to make it look like a tan. So if we let u equal 4x plus 1, therefore du dx is equal to 4. So somehow we've got to add a 4 into the equation. So I'm just going to say a quarter out there. I'm going to put a 4 in here. Well, if I put a 4 in here, it would be just du. I'm going to have 3 on 2 plus u squared. Now, if I bring that 3 out the front, 2. If I bring the 3 out the front, and I've got a 1 on top, what's the rule for that? Is it just 1 on? I thought it was a on. Bloody hell. Okay. Oh, they've got 1 on, so it doesn't really matter as long as I get 1 on. What am I thinking? Okay, so what do I want to get? I want to get, well, stupid, come on. Okay, I've got 1 on. So everything looks perfect with 3 on 4, so it's got to be one of these two. If u equals 1, if I put that into there, I get 5. And if u equals 2, I get 9. So 5 to 9, so it's going to be B. So that was number 8. Okay, that's equivalent to 1 minus cos 10x. What substitution can we make in? That's cos 10x, we can halve it. So I'm going to get 1 minus 2 sine squared 5x. So I would have 1 minus 2 sine squared 5x dx. So that would cancel with that. And then I'd have minus minus, so 2 sine squared x. 2 sine squared 5x sine squared. E. Okay. The graph of an antiderivative of a function of g is shown below. What graph does that look like? Signs like that, then that's inverse. So that looks like inverse sine. So when I integrate something, dx, I get sine inverse of x. So what's the original graph? What do we integrate to get sine inverse of x? I should just have a formula sheet with me. Sine inverse of x, it's 1 on root 1 plus x squared. 1 on sine x, integrate sine x. There, 1 on root a squared minus x squared. Okay. On root, we'll just say 1 minus x squared. So we get our graph. Zoom. Okay, so it's a V. But so that's when we integrate it. So when we derive it, it's all negative. Is it? Come back. The graph of an antiderivative. So if we were to derive this, graph of an antiderivative, if we were to derive that, it's always got to be positive, and it never gets to 0. Like it's high. It looks like it's not quite 0. So that's the derivative. No, if I look at the gradient of this, that's what I want to graph. I want to graph its gradient. So it's got a high value, and then it goes towards 0, and then it's got a high value again. It doesn't actually get to 0, so it's going to have to be above the axis. So it can't be that, because it's always positive, can't be that, it's got to be this one. And you can see it never gets to 0 because this doesn't ever get flat. Okay, the acute angle between A and B is, so 2, negative 2, 1. Okay, so in here we just put in our, bloody hell. So 2, negative 2, 1, comma, and then 2, 3, 6, I think it was. 2, 3, 6, interactive vector, angle. Can do it with degrees. Standard 79.01. Was that an answer? Can't even find it. Yep. Okay, in the diagram, LAM is the diameter of a circle. Yep. N is a point on the circumference of the circle. Yep, so we know that that angle's got to be 90. If R equals ON, that's R. S is MN. R is ON, so that's going that way. And LN is equal to LN. Okay, so this here is S minus R, which means that's S. The whole thing is 2S minus R. We want to go that way. Okay. Think about it. Okay, so here, R, that's R minus S to get from there to there. That's R minus S. So 2R minus S from there to there, and then plus S, which is 2R minus 2S plus, oh, that's not an S, but anyway, S plus S, which is 2R minus S, which is E. Okay, let I be in directions. Tan T, the particles given by I is particle A will be directly east of B when it's equal to directly east, so they've got to have the same height. So let's say T squared minus T is equal to 5T minus 8, T squared minus 6T plus 8, so T minus 4, T minus 2, so T equals 4 or 2. If I put T equals 4 into this one, A has to be directly east. So I put T equals 4 in, I get 16 minus 20 minus 4 plus 2 is 2. And then here, if I put 4 into that, I get 3 minus 4, which is minus 1. So 1 would be here, and then A would be east of it. That's okay. So that's good. If I put 2 into that, 4 minus 10 minus 6 plus 6 is 0. So A is at 0. If I put it into here, 3 minus 2 is 1. So that's the right of it. So it's not east, it's west. So it's got to be just 4. Whew, that's a thinker. Okay, the diagram below shows a particle in equilibrium on a plane of 3 forces. Which of the following statements is false? So 90, 150, what's that, 240, 120. So we can say Q on sine 60 is equal to R on sine 90, which is just 1, which is equal to P on sine 150, which is sine 30. Okay, R equals Q sine 60. R equals Q sine 60. That's not right. R is Q on sine 60, so it's got to be that one. Q equals R sine 60, yeah, that makes sense. P equals R sine 30, yeah, that makes sense. Q cos 60 is equal to P cos 30. Q cos 60, which is sine 30, is equal to P cos 30. Yep, that's right. I think it's A. Okay, an 80 kilogram person standing in an elevator that is accelerating downwards at 1.2 meters a second. So, 80g down, and we're accelerating down at 1.2 meters a second, which means that we have a force upwards of 1.2 times the mass, which is 80. So it's 80g minus 1.2 times 80. I don't know what that is. 80 times 9.8 minus 1.2 times 80. 688. Oops. Ah, bloody hell, wrong thing. It's there. Okay, a body of mass 2 kilograms is moving in a straight line with a constant velocity. Okay, when an external force, 8 newtons, is applied in the direction of motion for t seconds, the body experiences a change in momentum. Okay, change in momentum. So, mass times velocity is our momentum. So, mass times velocity, mv, is equal to p. So p is equal to 40. M is equal to 2. So 2v equals 40. So our velocity is 20 meters a second. That's what it's changed, 20 meters a second over whatever the time was. We don't know what the time was. External force of 8 newtons. So what else do we know? Force is equal to mass times acceleration. So 8 is equal to 2a. So a is equal to 4 meters per second squared. Now, if I've got to move up 20 meters per second, and I'm going at 4 meters per second squared, that's going to take me 5 seconds. Because after 1 second, you're going 4 meters a second, 8 meters, yep. So that's 5. Object travels in a straight line with an origin. As time t, its velocity per meters per second is given by that equation. Fine, okay. The object will back to its initial position. Okay, so the area has to be the same above and below. So that shape there is a semicircle with a radius of 2. So pi r squared halved, which is pi times 2 squared, which is 4 pi divided by 2. It's going to be 2 pi. So we want to know when this area is 2 pi. I'm just going to make it positive and then integrate. So root 9 minus t minus 7 squared, and set it equal to 2 pi from 4. Okay, so let's clear this. Where's square root? Right. 9 minus t minus 7 squared, x minus 7 squared. So when we integrate that from, what was it, 4 to some value, let's call it y. It's easiest, x, and that equals to pi, because I've made it positive by getting rid of that negative out the front. So 2 pi, solve for y, not x. 6.74. Closest to 6.7. Heights of all 6-year-old children in a given population normally distributed. The mean height of a random sample is found to be 115. Okay, so x bar is 115, n is 144. 95% confidence 6-year-old children is said to be that standard deviation is closest to. So S on, we'll say 1.96 because it's a 95. It's equal to standard deviation on root n, which is 12. That's equal to the distance off the mean, which is 1.2, because we know the mean's 115. So it's got to be 1.2. So if I times that by 12 and then divide it by 1.96, 1.2 times 12 divided by 1.96, 7.34. Looks pretty good to me. Was it 3.5? Yes, it was. It makes me feel even better. Local supermarket sells apples in bags. Stated mass of a bag of apples is 1 kilo. The mass of a particular apple is known to be normally distributed with a mean of 115 and a standard deviation of 7. A particular bag contains 9 randomly selected apples. The probability that the 9 apples in this bag have a total mass less than a kilo. Okay, so 9 times 115 is what? 1035. 1035. Okay, our variance is 49. So 9 times my variance of x, because they're 9 individual apples. 49 times 9. 441. Oh, that seems like a nice number. So if I square root that, I get my standard deviation. That's x bar. Of x bar is 21. Now I want to find the probability that's less than 1,000. So x, we'll call this, let's call it A for apple, is normally distributed with a mean of 1035 and a standard deviation of 21, which is 441. The probability that A is less than 1,000. So 1,035 and 21. Distribution, continuous, norm CDF. Let's say negative infinity to 1,000, 21, 1035, 0.4779. 0.4779. Farmer grows oranges and lemons. Oranges have a mean mass of, okay, so let's say a mean of oranges is 200 and a standard deviation of oranges is 5. Lemons have a mean mass of 70. So mu of L is 70, standard deviation of 3. Assuming from each type of fruit, what is the probability that florists in places that are randomly selected orange will have at least 3 times the mass of a randomly selected lemon? Okay, so 3 times the mass of a randomly selected. So we'll say the oranges are normally distributed with a mean of 200 and a variance of 25. This will be lemon is normally distributed with a mean of 210 because it's 3 times that. Now my variance of a lemon is 9. My variance of 3 of exactly the same lemons is 3 times, no, not 3, it's 3 squared. 9 times my variance of a lemon, which is 9 times 9, which is 81. So that is 81. Okay, now what do I want? This is a long sort of question for 1 mark. Orange will have, okay, so we want the probability that O is greater than L, which is the probability that O minus L is greater than 0. Okay, so what is the expected value of O minus L is going to be 200 minus 210, which is negative 10. The variance of O minus L is the variance of O minus the variance of L, but it's plus because when it's negative, you've got to bring it out the front and square it. So my variance of an orange, you remember that rule, var bar of AX is equal to a squared times the variance of x. So in this case here, we have, because it's minus, that becomes plus. Variance of an orange, 25. Variance of a lemon, 81. So it's going to be 106, which is the standard deviation of O minus L is root 106. Now, we want to know if we want to know greater than 0 for negative 10 with a standard deviation of root 106. So my expected value, distribution continuous, norm CDF, 0, upper infinity, standard deviation, root 106, and mean, negative 10. So 0.1657, which is here. So that's the probability that O is greater than L, and in this case L, I don't want to confuse them, but L is the 3 lemons added together. That's it, 20 multiple choice questions. Hopefully I haven't stuffed any of them up. I was probably a bit confusing in the way I explained things because I was trying to get through it in less than half an hour, which I don't know if I have done. But I don't think any of them are wrong. Okay, I'll come back for part 2 some other time. Bye.